Hi, this is a follow-up discussions on the non-parametric test, and which we discussed in the past video. We discussed from the Six Sigma Handbook 4th edition and McGraw-Hill's. And in this one, it is beautifully prescribed and parametric and non-parametric tests when to use it, right? And it is given in the chapter name is 10th chapter and page number 518, and it says, now I'm going to talk about it. For example, let's say you have one sample sign, right? For example, perform one sample sign. If you have the same, you have a, let's say you can find out the estimate or confidence interval. The same thing, we have a parametric, right? Parametric, you need to do one sample t test, tail test, and or one sample z test. You can do it. Let's say one sample Wilcoxon, when you are using it non-parametric. The same thing if you have a parametric data, and you can use one sample t test or one sample z test and all that. Let's say Mann-Whitney you have, and the same Mann-Whitney, if you have a non-parametric, the same equivalent in parametric is two sample t tests. You have a two mean you wanted to compare. What Mann-Whitney does is it compared two median, right? Because it's a non-parametric. Let's talk about the again non-parametric. I'm quoting non-parametric first, then followed by parametric. Kruskal values you have, and in this Kruskal value, perform the hypothesis test for the equity of population median for one-way design. Two or more population. This right? When you have two or more population, you can use one-way ANOVA. You already seen that. If it is parametric, one-way ANOVA. If it is non-parametric, it is Kruskal values. Let's talk about further. Mood's median test. Mood, M-O-O-D, apostrophe S, Mood's median test. The same thing you can do it in ANOVA also as well. And the Friedman test you have. And Friedman test you can do two-way ANOVA or paired t test you can do. And there is something called this is not very commonly used. For example, run test, you do not have anything parametric, and pairwise average you don't have any parametric, and pairwise differences you don't have. So you have this one, of course. Pairwise slopes you have. Let's say you're comparing the slope. Pairwise slope, calculate and store the slope between all possible pair of points where rho in xy or y x defines a point in a plane. The procedure is useful for finding the robust estimate of the slope line. If you wanted to find out, then pairwise you can do it if you are talking about non-parametric. For parametric, you need to use simple linear regression. And then let's talk about one more very famous thing, Levin test, right? L-E-V-E-N-E apostrophe S, Levin test. The test for equal variance. This method considered the distance of observation from their sample median and rather than the sample mean, right? And you have Bartlett test there. You have B-A-R-L-E-T-T apostrophe S, Bartlett test. And then you have another one, non-parametric analysis. Censored data you have. This is not widely used. You can do it parametric analysis. And then the same thing, hazard plots you have, non-parametric distribution, hazard plot, parametric distribution. So just remember that this is what we discussed today. Very beautifully it has given. It has given for non-parametric, it has given for parametric. But non-parametric includes one sample one sample sign, one sample Wilcoxon, Mann-Whitney, Kruskal, and Moore's, Friedman, run test, pairwise differences you have, and Levin test, and so on. In parametric, you have a parameter, and one sample t test, two sample t test, one-way ANOVA. These are predominantly you use it, right? ANOVA is a powerful one. Simple linear regression, Bartlett test, and all that. So I hope you enjoyed this video. Please do like, share, subscribe my channel. You have a wonderful day.